Okay, today we will go over several codes provided by Google TensorFlow and Hugging Face. We will try to use those code to create our own language model. Okay, so the first one is basic text classification, and second one will be classify text with Bert. And since those codes are provided by TensorFlow, so you can simply just use these two links, okay, to run the code on Colab. Okay. So the first one is basic text classification, and so let's see. Since it is a little bit difficult for us to analyze text-based data, so firstly we need to convert those text-based sequences, okay, words, into numeric vector. So that is the one of the ways. So let's go over these codes. But you have to notice that these two codes, these two Colab files, basically they are very primitive and sometimes very complex code. But however, next hour we will introduce Hugging Face. So you can create your own language model by using more simpler way by using Hugging Face packages. So, but I think it is worthy to go over these two codes in this hour, so that you can understand how actually a language model is created. Okay, so first, these codes use Keras and TensorFlow. Okay, so this example use a very classic dataset, which is MDB dataset, which is the movie interviews. So that for each movie interview, there will be some text-based comments. Okay, basically English, and there will be a label which indicate how different levels of actually it's 1 star to 5 star. Okay, so 5 star means the reviewer likes this movie, and 1 star means dislike. So basically we have labels of each comment. Okay, so here we can simply just download these movie comments by using built-in function. So there will be total 50,000 movie reviews. So half of the reviews will be used for training, and the other part will be used for testing. Okay. So there will be some files in the download files, but actually, if you unzip this file, there will be two different subdirectories. Okay, so in order to load those text files and its corresponding labels to TensorFlow, okay, we have a very interesting and very useful data structure, which is called TFDS. We have explained it before, but let's go over it again. Basically, if you want to load your text-based data to TensorFlow data set data structure, okay, you have to put your old text-based data in this structure. Okay, you need to have main directory, and it depends on how many different labels you have. So for example, it has 2 different labels for classification. So basically you have 2 subdirectories, and the name of this subdirectory, okay, in this example, class underscore A and class underscore B, that will be used. The directory name will be used as the class name. Okay, so there will be a lot of samples. So in these two subdirectories, okay, each sample will be in one txt file, and the name of this txt file is really doesn't matter. Okay, so you put your text in the txt file. One sample, one file. Okay, so in this case, we can use this specific function text dataset from directory to load all the labels and all the corresponding samples of this label to TFDS data structure. Okay, we have introduced fast text last week, right? So to feed the input data to fast text data structure, you need to arrange your text-based input by using underscore label underscore. So that is your label name, and here is your text, and each sample will be one line. Unlike TFDS, each sample will be one file. So basically, if you want to create your corpus, okay, so in DFTS, you need to create different files and put them into corresponding directories. But if you want to use FastText to create CBAR or skipgram language model, you have to put your samples in single file, and each line will be one sample, so that they're different. Okay, so after that, you create your data set by using list text dataset from directory function provided by TensorFlow Keras, and here, that is the name of your root directory. For example, it's main directory right here. Okay, but in the IMDb dataset, okay, you download from the network, the dataset root directory is imdb/trend. Okay, so after that, you can use this batch size right here, so that every time you retrieve one batch and the corresponding number of data, text data, will be retrieved. Usually we use 32, so every time you retrieve one batch, and there will be 32 text samples will be retrieved. Okay, so right here, line 7, line 8, okay, the validation split 0.2 means in this data set, in this directory, 20% of the data will be preserved as validation data. So the rest of the 80% will be used as training. So if you specify subset equals training, that means the corresponding return value row train ds will be the 80% of the data. Okay, so on the other side, right here, if you write subset equals validation, and the rest of the 20% data will be row validation ds. So in TFDS, they don't have split function. So basically, you need to use validation split and subset to specify how many different, how many portion of the dataset, how many portion of the data will be used in validation dataset and training dataset. Okay, so since in this MDB dataset there will be 50,000 dataset, But as we mentioned right here, half of the review will be used as the training, and half of the review will be used as testing. So in this case, in total there will be 25,000 in the training directory, and 80% will be used as the training, and 20% will be used as validation. And the other, right here, the other half of the data will be used as test. So now we have 3 different data sets. Okay. In the download file, okay, the I think it's right here. In this directory, okay, there will be two different there will be two subdirectory, and one is neg, the other is post, positive and negative. So there will be corresponding txt file in this subdirectory. So basically it is a binary classification problem. We have only 2 labels, so we have 2 different subdirectory. So it will create the right here class name by the corresponding subdirectory name. Okay, you can try it by yourself. So and of course this label will be further converted to 2 different integer based label, which is 0 and 1. Okay, so after that you can try this function, which is take. You can take one batch of the data from the training data set. Okay, so 32 different text and its corresponding label will be retrieved. Okay, so right here, so the first element will be the input data, which is the text-based text, and the second item will be the corresponding label. So right here we print the first 3 out of the 32 samples. So that is how you print the corresponding text and the corresponding labels. Okay, so that we can see that here's the text and here is the corresponding label. Okay. So after that, we still need some customized pre-processing. Okay, because the text we download from the IMDb dataset, there will be some that HTML file. So basically, you can perform any pre-processing you like in this customized serialization function. Okay, so here we can see that we set all the text to be lower, so that means there will be all lowercase text. Okay, so in this case, your dictionary will be smaller, right? So and it replaces all the HTML text. For example, BR, which it means return, right? Then line 3, it removes all the HTML text. Okay, and so after that, it removes all the punctuation, escape all the punctuation. Okay, you can customize this function as you like. Okay, if you don't know what function you should use or what preprocessing you should use, you can take a look at the preprocessing tasks in Orange. Okay, there are some preprocessing in Orange widget. Okay, So that is the first one is how you do the preprocessing, and the next one is do text vectorization. That means you have to build your own dictionary. So the first one, the max feature, indeed, in actually it is how the size of your dictionary. So that is 10,000. But as we mentioned before, to build your dictionary, usually there are some special tokens, for example, padding and unknown. Because you have only 1,000 tokens, but English word has even more than maybe 3,000 or 7,000. Sorry, 30,000 or 70,000. So there are some words cannot be preserved in your dictionary. So sometimes you need a special token to replace all the English word which is not in your dictionary. Okay, and after that there will be the most frequently used word in your corpus, which may be the or a. And for each word in the dictionary, you need to assign integer, which is the index, okay, to that word. Okay, so that is the max features. And the second thing is to create your model, you need to have the how many you need to specify the maximum length of your input. So right here it is 250. So if you input a text which is longer than 250, the rest of the words will be discarded. Okay? So you need to create a text vectorization to specify what is the preprocessing, customized preprocessing function you need to do. Okay? How many different words in your dictionary, and what is the maximum length of your input. And output right here in int means you have to specify the index by an integer. Okay, so after that you can adopt this dictionary. So after that you can see that we can convert, for example right here we get one batch from the training data, and here is one of the input data. Okay, so after we apply the which is here, after we apply the vectorization on the first review text and its corresponding label, and we will produce a NumPy array. So here the first word in your review is great. So of course it will be the lowercase after you perform preprocessing. And in your dictionary, it is the 86th word. And the movie will be the 17th, and it will remove the punctuation. So this dash will be removed. And especially will be this index, and the will be the second index, and so on and so forth. And in total, there will be 250 input, right? So if your review is less than 250, 0 will be used as the padding token. So basically, after you build your dictionary and you perform vectorization on your raw data, this vertex, okay, this array will be created. Okay. So and of course there are some other functions. For example, you can assign index, and the get vocabulary function will output its corresponding word, and so on and so forth. Okay, so in this case we apply text vectorization on the 3 dataset. Okay, so now the dataset is train, validation, and test DS. Okay, here's the number of the text in these 3 datasets. Okay, So after this cell, it's there are some hardware configuration. Okay, so we can simply skip this. Okay, after that, in this example, we need to convert the index to some numerical vector to represent our word. Okay, so in the lesson of text fast text, okay, we teach you how skipgram and Hsiao works. So right here is it's the same. Here we have an embedding there. Okay, the embedding there will receive the index based information, so that will so that is this one. So it receives such kind of index based embedding and try to transform it by using a neural network, a very simple neural network. So that yellow weight, it is exactly the same as we mentioned in fast test, Hsiao and skipgram. So basically, first, each index will be converted to a one-hot encoding, and the one-hot encoding is specify which index is used, and we have a trainable matrix. Okay, and here we define the size of this matrix is 16, and here that is the size of the dictionary. So for example, we have I think it is 10,000 rows. So the one hot, this one, it will select certain row in this big weight W. Okay, so this weight will be trained. So for example, if this word is list, so this will be represented by this row of in this big weight, as we mentioned in fast test and skipgram. Okay, so this embedding is what exactly what we teach in fast test. Okay, so after that, every word will have a numeric vector to represent each word. Okay, so after that, we have this interesting layer, which is global average pooling. That means if this sentence have 5 different words, so after we pass it through the yellow weight, there will be 5 individual vectors. So global average pooling means we simply just average these 5 vectors. So after that, we have one single vector, and its dimension is still 16. So after that, we have a very simple dense layer. It has only one neuron, which means we like to do certain kind of classification. Okay? In this case, the input is the reviewed text. So after this text vectorization, after this embedding, after a very simple dense neural network layer, it outputs a single value. The single value means it is positive content, a positive review or negative. So it basically it is to output. It is positive content. Okay. So that is the structure, right? So we simply just use binary cross entropy. So here is the softmax, and we use Adam and the binary cross entropy as our matrix. So after we input all the training data, and use the validation data set as the validation data, and we have 10 different 10 epochs. So after that, the model is trended. Okay, so as you can see that the binary classification accuracy is quite high, 91%. Okay, so we can use this trend model to evaluate the test data set, and it's at 87%, which is quite well, as right. So after that, we can plot the trending loss with epoch, right? So it decreased, and we can plot the trending accuracy and the validation accuracy, right? So as you can see that firstly, we have a vectorization layer, okay, and we have the model. The model has a weight to perform embedding, right? And right here, this export model, it has an additional activation function, okay, which is sigmoid. So after that, again, this model has this accuracy. Actually, I don't know why it put the sigmoid function after the model in this way. Actually, it can output this. It can put the sigmoid layer simply just right here. Okay, so but it really doesn't matter. Okay, so after that, we can try some data. Okay, so after that, we perform predict, so that we can see that this sentence, okay, will be used as the input, and the output is the corresponding how possible it is a positive review comment, or it is a negative review comment if this number is lower than 0.5, right? And after that, if you want to perform multi label, not binary classification, you have to use this way. You simply just create different subdirectories, okay, and the name of the directory is your labels of different classes, and that you can simply just perform classification with different, if multiple labels. Okay, so that's take some time to take a look at this view graph, these codes. Okay, the next thing we'd like to introduce is as we mentioned, it is a very simple classification, right? But here we like to show you, if you want to adopt language model in your text classification, how did you use the built-in Bert model? Okay, the example is exactly the same. We have the same input and we have the same output. We have to classify IMDb movie review comment, and we have to specify it is a positive comment or a negative comment. So most of the code will be the same. Okay, right here. But right here, TensorFlow has several built-in language model. Okay, you can see that this is the name of different models. So it takes some time to take a look at these paragraphs. Okay, and basically in this example, we use a very special model. Okay, so that is the Bert, small Bert. Okay, so if you want to take a look at you can simply just take a look at the wow, it needs right here. Okay, you can see that here Google provided a table, so that means although they are all transformers, okay, but they have different configurations. So right here, the L means how many different layers of attention layer you have. There are 2 layers, 4 layers, 6 layers, and 12 layers. So 12 layers, that means the entire transformer is more complex. Okay, so edge means how many different hidden neurons there in your transformer. So 128 to 768. So for some configuration, Google indeed names those configurations. So if you talk about, okay, I have a model which is Bert based, so that means it has 12 layers, and the hidden neuron is 768. Okay, so that is Bert based. So basically, in your so right here you can see that that is the configuration of a small Bert, and the pre-process will lower all English capital characters. Okay, so in here it has 4 layers. The hidden neuron is 522, and the attention is 8. So of course there are several different configurations, but in this example it uses this model. Okay, so basically if you want to use this model, the first thing is that you download the Bert preprocess model, okay, to perform pre-process, because this specific configuration, it has its own dictionary, and you cannot change this dictionary. So you need to use this specific function to download the dictionaries, the pre-processing process, which is all predefined by Keras. You cannot perform your pre-process. You cannot build your own dictionary, or you have to use the built-in pre-processing function and dictionary. Okay, so this is an example. For example, if we use this specific sentence as an example, and you can see that after you perform Bert preprocess mode on your text, okay, and you can see that 101 is this, okay, this 2023 is, and so on and so forth, so on and so forth. And here we can see that there are some paddings, and the input mask specify. Here is the text, and that 3 items will be the padding. So that you don't have to create your dictionary, because this dictionary is built-in dictionary. Okay, so after that, if you want to use the model, right, so you can simply just use the Bert model by using this specific function, and after you can use the model to process your pre-processed text, and you can simply just get the sentence, the vector. So that is quite easy. So here is the vector of your sentence, and it is the pooled output, which means it's only one vector to represent this sentence. And right here you can see that you can still output the vector of each word in this sentence. Okay, so we have 2 different types of output. So after that, you can define your own model. So right here, you cannot change it because it is predefined. You can simply just use the input layer, the preprocessor layer, and the Bert model. But after that, okay, you get the output, right? You can design your own classifier after your Bert model. So in this example, it still use a very simple model. It has a drop layer, and it has only one dense layer with 1 neuron without activation function. That's it. But actually, you can create your own classifier by using recurrent layers, bidirectional layers, convolution layers, more complex dense layers, dropout layers, anything you learned before. You can design your own classifier right here. Okay, and after that, again, after you have this model, okay, and as you can see that since there's no activation function, it put the activation function after the model, which is a sigmoid function. Okay, so right here, you cannot change this part because you use Bert. You need to use Bert's preprocessor, embedding, and dictionary. But you can design your classifier, which is attached after the Bert model. Okay, so after that, you can specify the loss function, which is binary cross entropy again, and you perform training. So here is how you define your optimizer by using Keras definition. So you have a version of Adam, you have your learning rate, how many steps, and here's the optimizer, matrix, and loss, right? And again, you fit by using the training data, test by validate by validation data, and here you train the data, and as you can see that the accuracy increased. So that means you read this model, okay? Read the review comment and try to use cross entropy to optimize this model, this simple model with the Y label. Okay. So again, here we can evaluate by using the test data, which is quite well, and we can output the training loss and the validation loss, training accuracy, validation accuracy with the epoch value, right? So after that, you can save this model because you train this model, right? You can save this model and use it later. And after that, again, we can do some tests. And as you can see that here is how possible it is a positive comment. Okay? So that's it. That is the how you use Keras and TensorFlow to use a language model to perform a very simple classification. So we stop right here. We will teach you how, but you still need to write a lot of codes to deal with the preprocessing, the dictionary, and your classifier. So next hour, we will teach you how to use Hugging Face, which is a convenient package. You can easily do so by using maybe less than 10 lines of code. Okay, we stop right here.